Second case, data will be arranged in ascending order in index segment. Third case, data will be arranged in descending order in the index segment. So we have covered three indexes now: normal index, ascending index and descending index. How to create them? Now, unique index. Create unique index I2 on EMP index of employee number. Such column list already indexed. Employee number, we have created the index, we have not dropped this index. So we are trying to create unique index on the same column. It is throwing an error. Such column list is already indexed. That means we can create only one index at any point of time on a single column, on one column. We cannot create more than one index. Now we want to create on employee name. It is throwing error. Cannot create unique index, duplicate keys found. Since we have duplicate values, we cannot create unique index if we have duplicate values in that ename column, or we can use sal column, any column wherever we have duplicate values, and that particular column unique index cannot be created. Let us see. Select star from EMP index. We have this much data. Now we wanted to create unique index I2 on ename column. Let us see now there is any duplicate data. We don't have any duplicate data now. Salary we have, see 12,250 is duplicate. So if you try to create unique index on salary, it will throw error. Here at present employee name doesn't have any duplicate values. So we can create unique index on employee name now. Index is created. We dropped it. We are creating unique index with ascending or descending. Yes, it is allowed. Unique index also can be ascending or descending. Now, user underscore indexes is the data dictionary view where the information about indexes will be stored. So now let us query user indexes to view the indexes what we have. See, we dropped all the indexes, only I1 and I2 are present now. So I1 is the normal index, which is uniqueness. See, index name, index type, table type, uniqueness, status, dropped, yes or no. I1 normal index, table type is table, it is non-unique, it is valid, it is not dropped. I2 normal index, but it is unique. Under uniqueness we can identify whether it is unique or non-unique index. So these two indexes are present in the data dictionary as of now. See, these are data dictionary views. User indexes, index types, index type, array types, index type comments, index type operators, user ind columns, ind expressions, ind partitions. This is for partitioned table. Statistics, subpartitions, join ind columns, part indexes, again for partitioned table, XML indexes for XML tables. So these are the data dictionary views where we get information about indexes. See, normally user indexes will have some information. If you want some more information, we can query other index, other data dictionary views to get the complete information. User ind columns. Index name is I1, table name is EMP index, column name EMP number. See, in user indexes we don't have column name, on which column the index is created, but the column name will be available in user ind columns. Here along with the table name, the column name is also available, and then whether it is ascending or descending, that is not there in user indexes, that will be there in user ind columns, whether it is descending index or ascending index. See, the last index what we have created is descending, and in case of I1, last one is descending. So this ascending or descending is also available in user ind columns. The ascending or descending and column name, column position is also available here. What do you mean by column position here? See, for the indexes on single column, it will always show as 1, but if it is composite index, then the number will be different. The exact column position will be displayed here. If we create a composite index on 3 columns, C1, C2 and C3 in the same order, then the column position will be 1, 2, 3. C1 will have 1, C2 will have 2 and C3 will have 3, that we see later in our composite index. That is what is column position, especially that is useful for composite index. Global index. Create index I3 on EMP index of job, global. The keyword global indicates it is a global index. Global index can be created on normal table also. Our EMP index is normal table, it is created. Now if you see user ind columns, I3 is there on job column of EMP index, which is by default it is ascending. When we do not use ascending or descending, by default it will be ascending. Drop index, we dropped it. We are creating I3 as local index. EMP index is a normal table. Underlying table of a local partitioned index must be partitioned. The table must be partitioned, then only local indexes can be created on that particular table. Normal table, it is not possible to create local indexes on normal table. Local indexes can be created only on partitioned table. So we are unable to create local index on normal table. So we need to create partitioned table for this purpose. Next is composite index. We have covered unique index, global and local index. Next is composite index. It is also called as concatenated index. So one index will be created on multiple columns. That is, one index is created on more than one column, but a maximum of 32 columns are only allowed to create a composite key. More than 32 it is not allowed. Create index I4 on EMP index of EMP number, ename and job. This is composite index. We are using 3 columns. Here EMP number is in first place, ename is in second place, job is in third place. So if you see the user ind columns, now we can find, see, index name is I4. I4 is present on 3 different columns. Table name is same, column name is different. EMP number, ename and job. But if you see the column position, now it is 1, 2, 3. EMP number is in first place, ename is in second place, job is in third place. In this order we have created a composite index. In this case, EMP number is the leading column. Ename and job are non-leading columns. So why do we want to know leading column and non-leading column? That we discuss in our performance tuning. What is the advantage of knowing of the leading or non-leading columns? But if we use leading column of composite index, index will be used. If we use any non-leading column of a composite index, even though index is present on that particular column, index will not be used. That is why we want to know what is leading column and non-leading column. So it is always better to use leading columns in the where clause for searching purpose. If at all we want to use non-leading columns, then we have to force the index using hint, then only index will be used. So this will help us in performance tuning. Dropping the index I4. Now see, by default ascending index is created on all the 3 columns. Now we create I4 as composite index on EMP index with the same columns but descending. Now all the 3 are descending. Now if you query user ind columns, I3 is descending. Again we dropped I4. Now we are creating I4 employee number as descending, e-name default, job as descending. If you query user ind columns, I4, see 1 and 3 are descending, 2 is ascending. See the column name field here. If it is ascending, the column name is displayed as it is. If it is descending, it is changing the column name also here internally. See, in our earlier case also column names are different. It is generating sequential names 6, 7, 8. Now it is 6, 8. This is 7. Because it is rearranging the data in descending order. So it is giving a new column name for that. We dropped index, creating another index, again composite, now default. See, it is created ascending index. Now we changed the order, e-name is in the first place, position is 1, job position is 2, EMP number position is 3. Since it is default, ascending index is created. That is why it has produced the same column names as it is. See, here we are using column index name format A10. That means now index name is displaying as 30 character length. We wanted to display as character length of 10. We want to reduce that. That is why we are formatting that. This has 10, index type as 30, table name as 12, column name as 15, num width as 10, width of number column as 10. Now if we see here, see, before index name is displaying as 30 characters, now it is displaying as only 10 characters because of this. Okay, now we are joining user indexes and user ind columns together using table name and index name, and we are fetching the data for EMP index table only, and we are fetching index name, index type, table name, column position, ascending or descending. In user ind columns we do not have index type. Index type is present in user indexes. What type of index it is? Now if you query, I1 is function based normal index. Why it is function based? Yeah, we are using descending along with column name. That is why function based index is created. Now let us create function based index. We use a function along with column name or an expression with the column while creating the index. That becomes function based index. Create index name on table name of upper of E name. One index is created. This is I5. I6 salary into 2. An expression, we are multiplying the salary with 2. Salary plus commission, 2 columns we are adding as an expression. In all these 3 cases, function based index will be created, which is I5, I6 and I7. If you see I5 function based index, I6 and I7 again function based index, but function based normal index. Column positions are always 1 and by default they are ascending. We can create function based unique index also. We can say create unique index name on EMP index of salary plus commission. Together should be unique. There should not be duplicate. In that case, we can create unique function based index. So here it will become function based unique, or under uniqueness it will say non-unique or unique. After function based index, we have reverse key index. Let us see how to create reverse key index and what is the reverse key index. When we create reverse key index, the data of the columns will be reversed while storing in the index segment. If we give ABCD, if we have the columns data as ABCD, when we create reverse key index, this data will be stored in the index segment as DCBA, means the column values will be reversed. Select E name from EMP index. This is how it is. Now we are creating reverse key index. So we just say create index name on table name of column name, at the end reverse. This will create reverse key index on E name column. Now if you query user indexes and user in columns, the name is I8. See, if you see I8, this is normal / reverse. See, if it is normal index, earlier case it is only normal. Now it is normal or reverse. Together it is displaying. 10 rows selected. Now let us see how the normal index will copy the data into index segment and how the reverse key index will copy the data into index segment. Let us take the data is like this. A1. First 5 characters are same. Last character is different. 1, 2, 3, 4, 5 like this. Now if you create normal index, the same data will be copied as it is into index segment. If it is reverse key index, the values will be reversed. One will become first beginning and then it will exactly reverse, right to left or left to right. This is how the data will be stored in the index segment. By reversing all the column values, it will store the data in the index segment. Now, how the reverse key index will help us to improve the performance in this case? If it is normal index, see, if when it go for range scan, now it has to identify based on the first character, it will check all are same, second character all are same, third character all are same, fourth character all are same, fifth character all are same, sixth character is different. So scanning of first character, second, third, fourth, fifth, waste of time. So when it reaches sixth character, then only it can identify. If you, instead of that, if you reverse this, the first character itself is different, so that it can easily identify in the range scan whether it falls in the first half or second half, like that. So this is how the performance will be improved when we have reverse key indexes in such type of data, when we have data like this in the table. Means the beginning few characters are same for all the rows, only the last character or last few characters are different. In that case, we can go for reverse key index, so that the performance will be improved. Next is clustered index. We cannot create clustered index as a developer. We need the help of DBA here. We need to have, first we need to create a cluster, then move the tables or blocks of tables into the cluster, then assign, then create an index on the cluster. So to create a cluster, we need to take the help of DBA. So we should have create cluster, permission, privilege, then only we can do that. That is why we do not have an example for the cluster index here. IoT, it is index organized table. This example is also not there in this file. So we will discuss about index organized table as a separate topic. Anyway, this is a special topic in our advanced SQL. So at that point of time, we will discuss about index organized table. It's nothing special. At the end, we specify organization index. If you want, I can copy this. Index organized table. I say EMP IoT. Columns can be anything. At the end, we specify organization index. This specifies the table is index organized table. So the table name is EMP underscore IoT. Columns can be anything. At the end, we specify before closing the semicolon, before the semicolon, we specify organization index. Now this table is an IoT, index organized table. And when we insert data into this table, data will only be stored in the index segment. Data will not be stored in the data segment. What is data segment and what is index segment? We discuss in our architecture, Oracle architecture. What are the different types of segments available over there? So as of now, we need to remember data segment will have only the tables data. Index segment will have the data of columns on which the indexes are created. This is how we create index organized table. And clustered index. First we need to create cluster. After creating the cluster, we need to assign the tables. Okay, clustered index. This example is created in Oracle version 10.2, that is 10G release 2. Create cluster, cluster name, it is throwing error, missing left parenthesis. We need to specify a column or multiple columns. Cluster created, create cluster, C cluster, C1 number, cluster is created. Now again we are using the same name, it is throwing error, it is already used because cluster will be stored in the database. Since it is a kind of object, so the name cannot be duplicated. We are using different name, cluster 1 with 2 different columns. Yes, another cluster is created. So if you want to create clustered index, first we need to create a cluster, then we need to create tables into that cluster or move the tables into this cluster, or while creating the table assign the cluster name for that. See, we are creating a new table. At the end we specify cluster name, and we need to specify one column from this table. Means we are creating a clustered table, means moving the table or assigning a table to the cluster. So now employee number we are using as a column for creating the cluster, means we are creating the cluster key on employee number. Table created. Select star from table, we don't have any data. Clustered tables cannot be used before the cluster index is built. If at all we are creating clustered table, first we need to create clustered index, then only we can use them. See, if you try to insert also, it will throw error, same error. Cannot be used before cluster index is built. How to create cluster index? Create index name on cluster C underscore cluster. On this cluster we are creating an index. The index name is I1. I1 we cannot use in this session. We used up to I8. So we use, where is that? I9. So now index is created. Now this index is the clustered index. If we query user indexes now, now we will get 11 rows